Assalamu alaikum everyone. This video is a demonstration for motion in two dimension, which is uniform circular motion. Let us start with it. This question starts as Tarzan swings in a vine of length 4 meter. A vine means a wire of length 4 meter in a vertical circle under the influence of gravity. Now, only reading this first sentence, it gave us an idea that there is a circle, in a vertical circle, a body is moving. And if they say under the influence of gravity, first of all, we're going to put that 4 meter radius because we know that the length in the circle is radius always. Then we're going to use the gravity word. Now, if you know that, first of all, you're going to make the line equal to itself, and then you're going to make it with the weight always perpendicular. The weight is always perpendicular to the tension. Here we have the force due to weight, but that is only a component of weight because weight does not equal tension. That will be Fw cos theta and it will be Fw sin theta. And the component of weight which is perpendicular, the line which is perpendicular will be this. And now you know how to put the arrows because we're using head to tail rule. This is how you make the figure, and this is tension. So you can easily see from the figure that Fw cos theta and tension, they both are balancing each other. So the effective component is Fw sin theta. Now you read more that vine makes an angle of 30 degrees. We're going to use the data. The angle is 30 degrees and we have speed given which is 6.5 meters per second. And what we are given the radius which is r is equals to 4 meter. So we have made a data. That is the three things we are given in our data. Now we're going to use to find. What do we have to find? We have to find centripetal acceleration. Okay, and we have to find tangential acceleration. Okay, we're going to put it here, and then they're also asking us for the net acceleration. Okay, so a is net is equals to question mark. We're going to mark it by 1 2 3, and then we're going to start a solution. Now the first thing that we need to find is centripetal acceleration. I guess it's pretty easy, you guys know, because we have the formula for centripetal acceleration which is AC is equals to V square upon R. And fortunately, हमें V भी given है, velocity भी given है और radius R भी given है. So we're only going to put the values 6.5 square upon 4, and first of all we're going to solve the square. The answer would be 4.42.25 and divided by 4, and then we're going to divide it simply. That's just mathematics, and our answer is found to be 10.56 meter per second square. Never forget to put the unit. Okay, so here our first part is complete. The second part, they ask us for the tangential acceleration. Now you think so that we can find the tangential acceleration by formula, but the problem is we don't have a authentic formula for tangential acceleration. So we're going to use the help diagram. Here we know that F net means all forces. What the force effective component is. First we're going to write the line that Fw cos theta is not the effective component, because अगर एक force इधर से 5 न्यूटन खींच रही है और एक force इधर से 5 न्यूटन खींच रही है तो उसका आंसर 0 होगा ना, दोनों बैलेंस कर जाएंगी. तो इसी तरह Fw cos theta और जो टेंशन है वो एक दूसरे को बैलेंस करें. तो जो हमारी टोटल फोर्स जिसकी वजह से हमारे जो बॉडी सर्कल में मूव कर रही है वो Fw sin theta होगी. We also need to write this line that as they both balance each other, so our effective component is okay. F net is equals to Fw. This is the most important part in this paragraph. If you have understood this, then the rest is easy for you. Now you need to figure out what is F net and what is Fw. Fw is actually weight and F net is equals to Fma, because you guys have read that Newton's second law, F is equals to ma. So basically this is the same, and W weight is always equals to mg. So we're just going to put the values in it and then substitute it accordingly. We also need to show that what we have done it. So I'm going to write it that. And now we're going to cancel the mass because it can be cancelled easily. Here m can be cancelled, and now we got this. Our derivation, our expression reduces to at is equals to g sine theta. Now you have gravity and you have theta, so you can easily find tangential acceleration. Our gravity is 9.8 into sine of 30 degrees. That would be probably 4.9 meter per second square, and meter per second square because it is also acceleration. They both have the same units. Centripetal acceleration and tangential acceleration have the same units. Now final steps is finding a net, which is really easy. You just have to find the square of AC square and AT square and solve them in an under root. It's the same method we use to find the resultant vector, if you remember the chapter vectors and scalars. You have the value of AC and you have the value of AT, so you can easily find it. It doesn't only apply to acceleration. Let me just tell you, because we have further numericals. If they're asking you for the net velocity, so you are only going to use Vx and Vy instead of AC and AT. If it's net acceleration, so you're going to use AC and AT. You just need to have two values, take the square and use them in under root. That's the simple method of finding the net acceleration. This is the mathematical. Now there's no physics in it. 135 under root 11.64 meters per second square, because it is also acceleration. This is the solution.